Hi everyone. Now let us discuss the double integral trapezoidal rule, which is used to numerically evaluate double integrals over a rectangular region. Suppose we want to evaluate the double integral f of x comma y dx dy, where a and b represents the lower and upper limits of x, and c and d represents the lower and upper limits of y. Since evaluating a double integral analytically may be difficult for some functions, we use the double integral trapezoidal rule to obtain an approximate solution. So to apply this method, the rectangular region is divided into number of equal subrectangles. So creating a grid of points, so as shown in the figure. So these grid points are classified into three different groups because each group contributes differently to the approximation. First, the corner points are classified into three different groups because each group contributes differently to the approximation. First, the corner points shown inside circles are located at the four corners of the rectangular region, since each corner belongs to only one subrectangle. So next, the boundary points shown inside rectangles lie on the edge of the region but are not corner points. These points are shared by two adjacent subrectangles. Finally, the interior points, which are the remaining points inside the region, are shared by four surrounding subrectangles. So using these weights, the double integral trapezoidal rule is expressed as I equal to hk by 4, sum of values in the circles, that is sum of corner values. Sum of corner values plus 2 into sum of boundary values. Sum of boundary values plus 4 into sum of interior values. Sum of interior values. Here h represents the spacing between successive points in the x direction and k represents the spacing between successive points in the y direction. So therefore, to approximate the double integral, we multiply the weighted sum of all functions values by the factor hk by 4. In the next example, we will apply these formulas step by step to compute the value of the double integral numerically. So now let us solve a numerical example using the double integral trapezoidal rule. The given problem is to evaluate the double integral 1 by xy dx dy using the trapezoidal rule. The given function is given by f of x comma y equal to 1 by x plus 1 by xy. So before applying the trapezoidal formula, we first divide both the x direction and the y direction into 4 equal parts. So for the x direction, the interval is from 2 to 2.4. Therefore, the step size is calculated as h is equal to 2.4 minus 2 by 4. That is xn minus x naught by n equal to 0.1, and k equal to 1.4 minus 1 by 4 equal to 0.1. Since both steps are equal, so h equals 0.1 and k also equals 0.1. So the next step is to calculate the values of the function f of x comma y equal to 1 by xy at every nodal points of the grid formed by this interval. So these functions value will then be classified as corner points, boundary points and interior points, and substitute into the double integral trapezoidal rule formula to obtain the approximate value of the double integral. In the next slide, we will prepare the table of nodal values and perform the numerical calculation step by step. So now we calculate the values of the function at each nodal points and apply the double integral trapezoidal rule. The table shown on this slide contains the values of f of x comma y equal to 1 by xy for every combination of x and y values. The column represents the x value ranging from 2 to 2.4 with an interval of 0.1. The row represents the y values ranging from 1 to 1.4, also with an interval of 0.1. Each entry in the interval is obtained by substituting the corresponding values of x and y into the function f of x comma y equal to 1 by xy. For example, when x equals 2 and y equals 1, the function value is 1 by the function value is 1 by 2 into 1, which is equal to 0.5. So similarly, when x equals 2.1 and y equals 1.1, the function value is approximately 0.4329. In the same way, all the remaining nodal values are calculated and they entered into the table. So now we apply the double integral trapezoidal rule. The formula is I equal to hk by 4, sum of the corner values plus 2 into sum of the boundary values plus 4 into sum of the interior values. So here h is equal to 0.1 and k equals 0.1. The corner values, boundary values and interior values are identified from the table according to their positions in the grid. So after multiplying each group of its corresponding weight and substituting them into the formula, so we obtain the approximate value of the given table integral. So the detailed numerical calculations and the final results will be presented in the next slide. So now let us substitute all the functions values into the double integral trapezoidal rule formula to obtain the approximate value of the integral. So we already know that h is equal to 0.1 and k is equal to 0.1. Therefore, the multiplication factor hk by 4 equal to 0.1 into 0.1 by 4. So next we classify the function values into three groups. So first the corner values are 0.5, the corner values are 0.5 and 0.4167, 0.3571, 0.2976. These values are added together with the weight of 1. Next, the boundary values are all the points on the edges of the grid excluding the corner. Their sum is multiplied by 2 according to the trapezoidal rule. Finally, the boundary values, these are all the boundary values. So these are all the boundary values. So their sum is multiplied by 2 according to the trapezoidal rule. Finally, the interior values. So the interior values are, these are all the interior values 0.4329, 0.4132, 0.3953, and 0.3968, 0.3788, 0.3623, 0.663, 0.3497, and 0.3344. So finally, the interior values which lie inside the grid are added together and multiplied by 4, since each interior point contributes of 4 surrounding subrectangles. So after substituting all these weighted sums into the formula and performing the calculations, we obtain I equal to, so I hope you understood today's session. In the next video, we will continue in the next unit. So thank you.